Good evening. We are the team TechScrum, and today we are here to present the mid-project demo of the P3 presentation. I'm Kevin, and Shelton will be presenting with me along with our project supervisor, Kidman. So this is the table of contents that we are going to go through today. First, we will introduce the background of our project and the existing features, and we will go through the project progress to talk about overall status. And next, we will focus on the details of the current developing or developed features. And finally, we will discuss about the future plan. So now let's talk a little bit about the background of TechScrum. So TechScrum is a software platform that is designed for agile teams to manage project from start to finish. Within the platform, we offer a range of features like Kanban board, Sprint, Epic, and etc. These features can help teams to improve task visibility and transparency, reducing communication costs, and help teams focus on core work through structured iterative processes. And here is the project progress. As we mentioned the existing features at the previous slide, we are developing the platform based on an existing code base. And from that, we developed new features including dashboard and real-time update, and optimize the code around Cypress and Jest testing, design patterns, and the multiple code standard. So now I will let Shelton to discuss about the main features.
Okay, so next I'm going to talk about the main feature we will be working on. First, I'd like to introduce one of our most important features, the dashboard page. The goal of this page is to help users track overall project process, identify delays early, and support sprint forecasting. On the front end, we utilize a rechart to virtualize three key assets: a pie chart for ticket status distribution, a bar chart for work types such as storage, box, task, and attack depths, and a stacked bar chart to reflect epic process based on ticket status. On the back end, we leverage the MongoDB's aggregation frameworks to process and optimize the data. This includes summarizing ticket status and work types for the current sprints and breaking down tickets information under each epic. By putting scattered data together before returning it to the client, we significantly improve query performance and made the front-end logic much simpler. So this dashboard page gives project measurements a clear and real-time overview of sprint activities, all in one place. All right, so next, another functionality we implemented is user authentication and token middleware. And we have refactored the entire login logic to make our system more secure and user-friendly. Now, once users log in, their session stays active without interruption. We support silence token refresh using JW token, so they don't get logged out unexpectedly. To enhance security, we also reroll the refresh token logic so that token cannot be proactively invalidated. This gives us better control. For example, if a user behaves suspiciously, we can remove their token and immediately restrict their accesses. And yeah, this lays the foundation for a secure, scalable authentication system across applications.
Okay, then we have our real-time update feature. In the original retro board, when a user add or modify items, the item entry will only be updated after reloading the page. This is because we only fetch item data from the database each time the page is loaded. Therefore, we plan to add a real-time update feature to solve this problem. However, implementing this feature requires changing the application server startup logic, which involves the integrity of the entire backend API. Therefore, ensure that all the original features are functional after the feature is developed is a significant challenge. So, as a solution, we plan to use the Socket.io library to implement real-time updates. This library is based on WebSocket and providing following features. So first, the event-driven architecture allows us to update items based on the pure events through broadcasting during CRUD operations. This enables separation from the backend API, ensuring that the original functionalities remain unaffected. And second, the room allocation mechanism enable broadcasting to specific user groups, ensuring that real-time updates do not impact other project teams using the app. And finally, the reconnection mechanism ensures that users on RetroBot do not lose real-time update content after disconnection. And next is the test framework. During development, we found that the existing testing framework are filled with a large amount of hard-coded data, which lacks flexibility and affects development efficiency when adding test cases. Therefore, we plan to optimize the testing framework. So the first issue to address is the flexible construction of the test data. To solve this problem, we adopted the builder design pattern. By implementing the corresponding builder class, we can construct the test data step by step. This allows us to directly call the corresponding construction method when we needed to adjust a specific field separately, which greatly improves the flexibility. And also by providing default values, we can reduce the duplication when creating data. And finally, we will discuss some of the code optimization work we have completed, which mainly focus on improving the development efficiency and testability. So for the development efficiency, we have fixed the front end and back end data interface consistency. And also we remove some of the redundant endpoints in the backlog services. And also we fix the redundant input in the ticket service function, also along with the spelling errors. And then for the testability, so we have add some action simulation for surprise tests, such as the drag and drop, and also we fix the crowd validation logic in the epic feature. And also we add some test cases for backlog, epic, type, ticket, and etc.
All right, let me talk about what's coming next. It's our future plan. First, we're working on real-time updating, like we stated earlier, and we're building on top of our existing WebSocket infrastructure and plan to extend it across the entire system. This is especially important for collaborative use cases. For example, when one user drag a task card on their board, other can see the update instantly and without needing to refresh. It's all about maintaining real-time synchronization across the team to enhance productivity and coordination. All right, and second, we are planning to introduce an AI-powered chat assistant. So user will be able to interact with the system through natural language. For example, simply saying, hey, give me creates a high priority text code, improve search accuracy. Yeah, like this. So behind the scenes, this assistant will use OpenAI's API to interpret user intent and safely trigger back functions, such as creating, updating, or retrieving tasks. And because this assistant will deal with sensitive project data, and we are being careful. So we only allow it to run specific backend functions that we clearly define and approve. So this way, the AI can do anything unexpected, and we keep a good balance between ease of use and security. In the future, this assistant could also provide intelligent support, like predicting task completion time, identifying overdue items, or summarizing project status. So these upcoming features are designed to significantly improve team efficiency and deliver a more intuitive and intelligent user experience. Yeah, thank you for guys for listening.